companies, so it's not a cloud out there. Google has a cloud, right?
Google has a cloud, Microsoft has a
Like,
cloud.
everybody has their own cloud.
That's right.
Is that right? Every clouds
Kind of, but all the clouds talk to each other.
talk to each other.
Yeah, sort of. A cloud can do, or the cloud compute can do two things. It can store stuff, and it can process stuff. So you can do calculations in the cloud, and you can store photos in the cloud. That's a good way to think about it. The basic infrastructure that's there, so it's Intel servers running Linux or Windows or some operating system. That's all pretty standard across everything. There are a few varieties, but there's not much difference. The thing that makes it, and the way you're putting it proprietary, makes it unique, it's not really proprietary, is the software that's running on this. So Google has its software running on this baseline hardware that's communicating to you and allowing you to do Google Drives. And Dropbox has software sitting in a cloud somewhere doing that. And in many instances, like Amazon, it's actually Amazon hosts some of Apple's cloud services. So it's not so much proprietary, really the proprietary nature goes back to the software that sits there.
That's right, it's the way you interact with it, right? And actually one interesting thing that's happening in that part of the industry is, if you would have looked at a data center, right, which is what the cloud is essentially replacing, or it's becoming an enormous data center, that used to be owned by people like Cisco, right, where they made the hardware, they made the software, and one of the things that has driven the cloud to be so inexpensive is companies like Amazon and Microsoft and Google doing something called white boxing, right, where they are going out and they are making the contract manufacturers, now we call them known as ODMs, or original, what does ODM stand for?
Original design manufacturer.
Original design manufacturer. They will provide very generic hardware based on Intel chips and PC boards, and these companies will design their own software to make this computer, not really care whether the hardware was designed to be a storage computer or a compute computer or a specialized computer, the way that, for instance, a Cisco or an HP or an IBM would have it. So it becomes a resource that's very attributable to whatever the customer demands. And this makes it very, very efficient. Similar to if you're using your computer right there, right now you're not using a lot of compute power in that computer, right? It's probably somewhere around 3 to 4% of the total resource that's actually being used. Maybe even less, actually, at the moment. It's in hybrid. It's in standby, right? Well, when you put thousands or hundreds of thousands or millions of those processors into the cloud, you can now get much, much higher utilization out of this asset, out of this resource, which makes it so much more economical to use it. Which just means, though, that now you need to connect all of these different clouds together. You need to connect these buildings together. You need to connect these computers together. You need to connect the clouds together so that they can talk to each other and they can process and store and exchange information with it.
So yeah, if you look at that in a data path, you might consider, hey, one of the things in the cloud is Amazon Video. So you're going to watch a video. Now, when you watch that video, you have absolutely no idea where the video is coming from and how it reaches you. And if one of their data centers goes down or somebody takes a backhoe and rips up a particular piece of fiber, the network will move data around in a way in which that your video won't be interrupted. And it may be over a wireless network, it may be over a wireline network, that may be in any fashion there. But this is why that interconnect is so critical. What goes on? So